Hi everyone, we are from Group 10. So I am Muhammad Afiq bin Hazli. My group members are Muhammad Anak, Thaqeef and Cosmartin. So today we will be doing our first assignment, assignment 1. So we'll be explaining question number 9, which is a Rod's Law question. So let's read the question first. So using Rod's Law, calculate and plot the XY data at total pressure. So this is the given data that is given, the vapor pressure for N-hexane and N-octane. It's the system that we're dealing with today. So the question asks us to plot XY data, plot the boiling point diagram, and what will be the relative amounts of liquid and vapor phase for a mixture containing 0.545 mole fraction of hexane at 100 degrees Celsius. So looking at this question, we have to firstly do another update this table by implementing Rod's Law. So firstly, I've done it beforehand, so I'll be explaining to what I've done. So initially we know the N-hexane is more volatile than N-octane. So to make things easier, I've classified my pH as partial pressure of N-hexane and POS, partial pressure of N-octane, to make it easier to describe. So PVH is the vapor pressure, PVO is the vapor pressure for N-octane. So this is Rod's Law. So it states that pH equals to Px, X which is mole fraction of N-hexane in liquid phase, X times the vapor pressure of hexane. That is the partial pressure of N-hexane. So PO is the same thing, partial pressure of N-octane times the mole fraction. So since the total pressure is the partial pressure of both respective substances, so we can conclude it as the total pressure equals to the mole fraction of hexane times the vapor pressure of it plus the since hexane is X, so octane will be 1 minus X, so the vapor pressure of octane times the mole fraction of octane. So from here we can find out the mole fraction of N-hexane in vapor phase. So this I profiled it as Y. So Y times total of pressure equals to vapor pressure of N-hexane